Hi everyone. Today's topic, let's we all see about what is polynomial regression. So in our earlier videos, we had already learned about what is regression and correlation, and in the regression what are the kinds of regressions: linear regression, multiple regression, and logistic regression, and the last one is polynomial regression. So today we are going to learn about what is polynomial regression. So we already know about what is regression. So this regression we use it for the relationship between two or more variables. So that is called the regression. So in regression, to do the analysis, we need some kinds of analysis. Those are linear, multiple. We already know about what is linear regression and multiple regression and logistic regression. If you have any doubts, please go through for whatever the videos we were uploaded in our previous sessions about linear, multiple and logistic regression. And the next one is polynomial regression. So the polynomial regression, it is also one of the type of regression, and it is a form of regression analysis in which the relationship between the independent variable x and the dependent variable y is modeled as a ninth degree polynomial in x. So this is the just basic meaning of what is polynomial regression. As we know, we are having the dependent variable and independent variables, and based on that we need to find out the relationship between those two variables. For that we use this model as a ninth degree polynomial in x. So this is about polynomial regression we are going to learn about. Here we can see in the graph about the dependent variable and the independent variable, where we can consider the relationship between both variables, and there we can see that we are modeling as a ninth degree polynomial in x. So for that purpose we use this polynomial regression. So let's go through deep what is this polynomial regression, why we need this polynomial regression in our video. So we already know about the meaning of this polynomial regression. This is mainly for the to check the relationship between the independent variables, and the dependent variables are modeled in the ninth degree polynomial. So these polynomial regression models are usually fit with the method of least squares. So the least square method minimizes the variance of the coefficients. So, and also in this polynomial regression, it is a special case of linear regression where we fit the polynomial equation on the data with a curvy linear relationship between the dependent and independent variables. And also we can clearly go through in depth by following some of the examples also why we need this polynomial regression. So, according to the regression data only, we use this polynomial regression for to check some of the data what we need. Like we saw two variables in our data set where correlated, but what happens if we know that our data is correlated but the relationship does not look linear? So hence we can, depending on what the data looks like, we can do a polynomial regression on the data to fit a polynomial equation to it. So for this we if we try to use simple linear regression, then the linear regression line won't fit very well. It is very difficult to fit a linear regression line for the given sum of the data. So hence we can try to use this polynomial regression to fit a polynomial line so that we can achieve a minimum error or a minimum cost function. And for that we use some of the functions for this polynomial equations. And for example, we can see like So this, for example, we can see this polynomial regression. It's very helpful tool for studying the correlations between two sets of event. So like that only. For if you want to predict the spread rate of COVID-19 and other infection diseases. So for this type of examples, this polynomial regression is a one of the main analysis. We can make some predictions on that. And also we can see that simple linear regression means it allows you to estimate the linear correlation between the two variables. If you see the linear regression, here we can see that it allows you to estimate the linear relationship between by following the best fit line between the two variables. Similar to that, usually the more time you spend on the physical activity and the bigger your, for example, this weight loss program and all, there is a linear correlation here. So we like that we can in multiple regression we use this is related to simple linear regression only, but instead of showing the correlation between just one dependent and one independent variable, we can consider several independent variables. For example, we can consider hours at the gym and daily sugar intake and calories you are consumed to predict for the weight loss. So for that purpose we use the multiple regression. So, but this polynomial regression, it is needed when there is no linear correlation fitting all the variables. Why we need this polynomial regression means there is no linear correlation fitting by following the all the variables. So instead of looking like a line, it's look like a non-linear function. Okay, why this was like a non-linear function? Because it's there is no linear correlation fitting by using those all the variables. So for that purpose, for that is the reason it's looking like a non-linear function. And we can see that this polynomial regression is useful in many cases, like relationship between the independent and dependent variables is not required to be linear, and you get more freedom in the choice of the data sets and situations you can be working with. So this method can be applied when simple linear regression underfits the data. So when you study the data, when you observe that the data is not fit, that time you definitely you can use this polynomial regression. And types of polynomials here we can see. So we are having the three types of polynomials. One is linear, that is following the axis like ax plus b equal to 0, and quadratic polynomial ax square plus bx plus c equal to 0, and cubic will be like this ax cube plus bx square plus cx plus d equal to 0. These are the three types of polynomials here we can follow for to do the problems. So, and also here we can see the simple linear model and the polynomial model. The simple linear model, by following the best fit line between the dependent variable and the independent variable, there we can see y equal to b0 plus b1 into x, the independent variable whatever it is in the linear model. But whereas in the polynomial model, for the large type of data also we can use this polynomial model y equal to b0 plus b1 into x1 plus b2 into x plus so on, like for the ninth degree model. For like that, for we use this polynomial model, and this curve line we can observe it's not a best fit line and it's like a non-linear model. Here we can observe in the polynomial model compared with the simple linear model. So if you know that what linear regression is, then you can probably understand the maths behind this polynomial regression too. So this linear regression is basically the first degree polynomial. So like that we can see the simple linear regression will be like this y equal to b0 plus b1 into x1 for one independent variables with a dependent variable, whereas multiple regression is as follows y equal to b0 plus b1 into one independent variable plus b2 into another independent variable plus so on. How many independent variables are there in the multiple linear regression? Whereas in the polynomial linear regression, we can see nth term b0 plus same as like a multiple regression b1 into x1 plus b2 into x1 square plus so on and bn into x1 power n. So, according to the definition of polynomial regression, here we can see is modeled as a ninth degree polynomial in x. X means the independent variables, whatever we are having the data. So, like this type of equations, we need to follow as same as we followed in the simple linear and multiple linear regression. So, the formula for polynomial regression. So, the main theme of this polynomial regression is to find out the ninth degree value. So for this, to find the right degree of the equation in that, in order to find the right degree for that, we can use forward selection and backward selection also. Forward selection means this method increases the degree until it is significant enough to define the best possible model. Backward selection means this method decreases the degree until it is significant enough to define the best possible model. Like this also we can use this polynomial regression. And for this polynomial regression, we can use the matrix multiplication also to calculate. So better than that, we can use this formula for to do the calculation of the polynomial regression. So this polynomial regression, it can reduce your cost returned by the cost function. It gives you a regression line, a curvy linear shape and makes it more fitting for your underlying data. So by applying this higher order polynomial, you can fit your regression line to your data more precisely. So that is the one of the best use by using of this polynomial regression. And also we can see that the formula for the polynomial regression now is that we can see f of x equal to b0 plus b1 into x1 plus c2 into x square and so on cn into x power n, where n is the degree of the polynomial and c is a set of coefficients whatever we have and x is the independent variables. So according to this, like this formula we need to apply for to find out the polynomial regression. And also the formula we can apply based on the data a equal to summation y into summation x square minus summation x into summation x into y whole divided by n of summation x square minus summation x whole square. And whereas for the b data like this n of summation x comma x into y minus summation x into summation y by whole divided by n of summation x square minus summation x whole square. So like these formulas we can use for to calculate the polynomial functions. So this polynomial function, it is a process of finding a polynomial function that takes the form of f of x equal to like this. So we know that n is the degree of the polynomial and c is a set of coefficients. So the polynomial regression, we can try to find the ninth degree polynomial function which is the closest approximation of our data points. So here we can see a sample random data set which has been regressed up to 3 degree and plotted on a graph. 3 degree plotted on a graph, here we can see that. The blue dots represents our data set and the lines represent our polynomial functions of different degrees. So the higher the degree, closer is the approximation, but higher does not always mean right, which we will discuss again. So based on the data, we can see y equal to the values which we can see 100, 100 and 1 to 4 and 142. Based on the dotted lines, we can multiply those x and y values by following the formula of C0 plus C1 into x plus C2 into x square, like that. For the up to 3-degree values, we need to add the values by following this function in the form of like this. And also here we can see, to understand the math behind this above analysis, let's start by constructing a line function that passes through the 2 points. The 2 points we can see like 1 comma 1 and 6 comma 9. So the general formula for this equation of line, we know that y equal to mx plus b. We know how to substitute these values. 1 equal to m of 1 into, if we take 1 comma 1 values plus b, and if we take 9 comma 6 values, 6 comma 9 values, like that. We need to apply in the formula. So based on this formula, our job is to find the two unknown m and b in the above line equation. So by putting the sample points in the above equation line, we can solve for m and b using substitution method. We know that the substitution method, how we can do. Like this we can do for solving the m values and b values by substituting the values x and y values in that. So we will get m equal to 8 by 5 and b equal to minus 3 by 5. So now substituting all m and b values in that, in our linear equation, we get the formula of like y equal to 1.6x minus 0.6. So this above algebraic method, it works best for small number and 1-degree polynomials, but for higher degree polynomials we will be using matrices, and linear algebra also we can use. But so we know that how to do in matrices. By using matrices also we can solve the m values and b values like we did in the same with the formula of y equal to mx plus b. With matrices also we can get the same values, and also we can see we get the same equation by line using the matrix and linear algebra. So this method work great when we have 2 points, because we know we can draw a straight line passing through them, but we cannot assure the same when we have more than 2 data points. So here we can use this formula to find the coefficients of linear equation. This formula we can use to find the coefficients of linear equation y equal to bx plus a. Y equal to bx plus a. To find the coefficients of linear equation y equal to bx plus a, to find the b value and a value, we can apply this formula. For a value, we can use this formula. For b value, we can use this formula to get the answer. So by these equations, we will give us the general formula for a polynomial function of any degree. So in this regression analysis, we will try to find an equation of line which is close approximate of actual training data points. So we use a method called sum of least squares to derive our equation. So what to do is find all the possible line equations for a given set of points, data points, and select the one which has the least squared sum of errors. Those we can say as residuals. Residuals or errors being the difference between the predicted value and the actual values. You can see the residual or predicted values here we can see. So sum of least squares, we had already knows how to find the sum of least squares. Summation of ni equal to 1 in the bracket yi minus f of xi whole square. Like that we can use the formula to find for the summation values. Like that only we can find out this a value and b value also, to use that for the line equation. So what are the advantages of this polynomial regression? So it provides the best approximation of the relationship between the dependent and independent variable. So for a broad range of function can be fit under it. And also this polynomials basically fits a wide range of curvatures. As we had seen in the examples, this is the best use of for the polynomial equations. And also we can see some of the examples of this polynomial regressions. For example, why this polynomial regression is used in some examples, like some practical examples where this polynomial regression we can use means for the death rate prediction. So means when accidents happens like fire accidents or tsunamis or some of the epidemics, it is important for catastrophe management teams to predict the number of injured or passed away people so that they can manage the resources. It may take days, if not months, to mitigate the consequence of such events, and the team must be prepared. This polynomial regression allows us to build flexible models that reports the potential death rate by analyzing many dependent factors. Like we can see the recent examples of in COVID-19 pandemics, these factors can be whether the patient has any chronic diseases, how often they are exposed to being in large groups of people, or whether they have access to protective equipment. Like these factors we will consider to analyze. And also another example we can see tissue growth rate prediction. So tissue growth rate prediction is used in different cases. Like firstly, this polynomial regression is often used to monitor for the oncology patients and the spread of their tumors also. This type of regression helps to develop a model that considers the non-linear character of this spreading. So this tissue growth rate prediction is also used in monitoring ontogenetic growth also. So means it enables doctors to monitor the development of the organisms in the womb from a very early stage. And also we can use this polynomial regression speed regulation in software. So today, more and more speed regulation software systems powered by ML, this machine learnings are aimed at not at punishing violators of road conduct, but at preventing unsafe behavior. So predictive modeling with the help of polynomial regression allows you to search for patterns in drive behavior and inform them about the necessity to follow the rules even before they overtake the speed limit. So some of the measures they have been reported to be more effective and decrease the number of accidents on the roads. Like for so many purposes, this polynomial regression is simply useful and powerful tool for the predictive analytics. And also it allows you to consider non-linear relationship between the variables, and we can reach the conclusions that can be estimated with high accuracy. So this type of regressions, it can help you to predict disease spread rate, calculating fair compensation, and also implement a preventive road safety regulation software. So for this type of large data sets, we can use this polynomial regression. And we can see about we understood right about this polynomial regression is a model in the relationship between the independent variable to the dependent variable as a ninth degree polynomial. According to the equation also we can understood. So this model a wide range of relationship between the independent and dependent variables. So means if the relationship is curvilinear, a quadratic or cubic polynomial can be used to model the relationship. The degree of this polynomial equation depends on the complexity of the relationship between the independent variable and dependent variable. So a higher degree polynomial can better fit the data, but it may also overfit the data and result in poor performance on new data. So this can be performed using some of the some same techniques what we had seen in the linear regression. Means the coefficients of the polynomial equation can be estimated using the least square methods, as we had seen in the form by following these formulas. By following the least squares methods, which minimizes the sum of squared errors between the predicted values and the actual values. So we use that for the regression analysis. So why this name was happened to the polynomial regression? So the name polynomial regression comes from the fact that this type of regression analysis models the relationship between the independent variable and the dependent variable as a ninth degree polynomial. So a polynomial is a mathematical expression that consists of one or more items where each term is the product of a constant coefficient and one or more variables are raised to a non-negative integer power. For example, we can say x power 2, comma 3x and 4, or these are all the examples for the polynomial terms we had seen in the mathematics. And so this polynomial regression reflects the fact that this type of regression analysis uses polynomial equations to model the relationship between the independent variable and dependent variable. So this polynomial regression is the main difference we can know about the linear and polynomial regression. They have differ in their approach and their applicability. That's it. Means the linear regression models assumes a linear relationship between the dependent variable and the independent variable. So the model is expressed as linear equation. We know that y equal to b0 plus b1 into x. So and same way, this polynomial regression extends the linear regression by adding higher order polynomial terms to the models. Extends. This is the extension of simple linear regression only. The model is expressed as like this: y equal to b0 plus b1 into x1 plus b2 into x1 square plus so on till ninth term, ninth degree. So this is the last ninth degree of the polynomial. Polynomial regression, it can provide more accurate predictions for non-linear data sets. This is the main point we need to remember, and it can be more flexible in capturing the complex patterns in the data. And also it can be more complex to implement and may overfit the data if the degree of the polynomial is too high. The same way in this polynomial equation also we need to evaluate the matrix. For that, mean square error and root mean square and r square and adjusted r square values also we need to know to calculate this the same way, and we need to apply those values in the formula and we'll get the values. So this polynomial regression is useful in various sectors like in economics and in engineering, medicine, marketing and in finance and agriculture. In so many areas, this polynomial regression is useful. For example, in marketing, how this polynomial function is useful. This can be used to model relationship between sales and marketing variables like advertising spending, pricing and promotion. And that's another example we can see a polynomial regression model can be used to predict the effect of advertising spending on sales. So for this type of analysis also we can use this polynomial regression in marketing. And in medicine areas, how we can use this polynomial regression? It can be used to model relationship between health outcomes and risk factors like such as age, gender and lifestyle. And also we can see this can be used to predict the risk of heart diseases based on factors like age, blood pressure and cholesterol levels. So in so many areas this polynomial function is useful for to get the data of the nonlinear functions. And in engineering also we can use this is polynomial regression is commonly used for modeling the relationship between variables in physical sciences like as temperature, pressure and time. And the example we can see it can be used to predict the behavior of a material under different environmental conditions. And also in economics also we can use this polynomial regression model to predict the effect of education level on income based on the model of relationship between the economic variables such as income and education. So for this type of analysis, this polynomial regression is a widely used technique in various fields for modeling the relationship between the variables in a non-linear way. For that purpose, we can use this polynomial regression, and it is a very important function in the regression analysis, as we can see. If you are simply understood about what is linear, multiple and logistic regression, then you can simply understood about this polynomial regression. So this in this the degree of polynomial regression means what? So the degree of polynomial is the highest power of the independent variable. So there you can see the highest degree of the polynomial. Here you can see the n, dn into x1 power n. So that is the highest power of the independent variable in the polynomial equation. For example, in a polynomial of a degree 3, the independent variable is raised to the power of 3. So, and also we should be clear about what is simple linear regression, the difference between simple linear and polynomial regression also. The simple linear regression is it's a linear model. We can see that between the dependent and independent variable, we can find the linear relationship between them. Whereas in the polynomial regression, a non-linear model that allows for a more flexible relationship between the variables by fitting a polynomial equation to the data. And also we can know about what is overfitting in the polynomial regression. Overfitting occurs when a model fits the training data too closely and captures noise and like that, but means which leads to poor performance on a new data. So overfitting can occur when the degree of the polynomial is too high for the amount of the data available. So in conclusion, we can say about this polynomial regression. Polynomial regression, we know that it's one of the statistical method where we use functions with higher exponent to form more complex forms. Simple and multiple linear regressions are perfectly fine models but not fit for all use cases. And also it allows us to model complex nonlinear relationship between input and output variables. By adding these polynomial terms to the linear regression model, we can capture non-linear trends and make better predictions on the target variables. So this is about polynomial regression and why we use this, and where in which areas we are using the polynomial regression, and what is the meaning of polynomial regression, and advantages, and also the formula, and what is about 90-degree polynomial, the difference between linear and polynomial regression, and based on by following the quadratic equation how we can find out the a value and b values. And in the same way we had seen about how to find the values by following the linear regression y equal to b0 plus b1 into x1, the same way of polynomial regression. And the types of polynomials are linear, quadratic and cube. According to the given data, we will apply these types of polynomials in the problems. So this is about the basic explanation of what is polynomial regression and the formulas and where we are using the polynomial regression and what is the use of this polynomial regression. And in the coming video, we can just see about we can just do some of the problems, how to solve the problems by following the real life examples and by applying the formula of ninth degree polynomial, degree of the polynomial. And in the next coming videos, we can see the examples of those.